Hello students, today we are going to start a topic polynomials from class 10 standard mathematics. For this we need to know about some particular point and we need to know what is the syllabus for Cbse class 10 standard polynomial chapter. Let's see. First point is introduction. In introduction, what we need to know? In introduction, we need to know about what is polynomial, the basic definition and some kind of example, types of polynomials and this type of things. After that, graphical representation. Graphical representation. This is the second topic for polynomial. Next, zeros of polynomial. This is one of the most important parts, zeros of the polynomial. And number 4, relation between zeros and coefficients. These are the basic 4 topics in the chapter polynomials and we are going to discuss about it. First, introduction. First we need to know what is polynomial. So to know about this polynomial we need to know about 2 particular terms. First term is variable and second term is constant. These are the 2 terms we all know about it, variable and constant. Now, if I write a variable x, now I want to ask that what is the power for this x? You can easily say that the power of x is equal with 1. If I write x square, then you can say the power of x is equal with 2. Now, if I am going to write a or b or c like this type of thing, then you can easily say that these are the constants. So, variable and constant. Now the question is, x, can we write only x as the variable? No, we can use any kind, y, z. These are all represent the variable in algebra. In case of constants, a, b, c, these are the constants or any numerical values. Numerical values like 1, 2, 3, 4, 5 or minus 1 or any kind of fraction values, any numerical values you can take as constant. Now, what is polynomial? For this, we have already learned about the variable and the constant. Now, if we mix both of them and if we form an expression, that expression is called as the polynomial. So that means polynomial is an expression mixed with variable and constant. Now we are going to see an example how we are going to mix the variable and the constants. Suppose I am writing x plus a. In this case, you can see that one variable part is here, x, a constant part is here, and we mix this 2 part using plus sign, and this become an expression. So this is an example for polynomial. Now, if I write x square plus x plus 1, then you can also see that this is also a polynomial. Why? Because we use variable over here and constant. In case of variable, you can easily see that x square, that means power of x is equal with 2, x, power of x is equal with 1, and a constant part, which is 1. Now, you may have asked a particular question that, sir, can this only, if I write constant, can this be represented, or can this we can say as polynomial? Yes, we can see that this is also represented as polynomial. We can say 5 as also polynomial. Why? We can represent 5 like this way, 5 into x to the power 0, and all we know that x to the power 0 means 1. So that means this is also can be represented or also can be say as polynomial. But this particular polynomial where the power of x is equal with 0 specially represent as the constant. So that's why we didn't say normally 5 or normally 6 as polynomial, we directly say this is as a constant. Now if I write only x, no constant part is there, no constant part is there, then sir, this is a polynomial? Yes, why not? X plus 0. What I said earlier, that the mix of variable and constant, this is variable, this is constant. So that means if I write only the variable or only the constant part, that is also represented as a polynomial. But in case of this, where we are not writing the variable part, that is directly called as the constant. But in case of this, where no constant is there, that is also a polynomial. Now we need to know about the classifications of polynomials. So polynomial, what we understand, polynomial means the expression which contains a variable part as well as a constant part. Now we need to know about the classifications. So first we are going to understand about the classifications. First, x to the power 0, this is called as constant. Why? Because this is equal with 1. So this is constant. Next, x. If we write x, the power is equal with 1. So this is called as linear. After that, x square, power is equal with 2. So this is called as quadratic. Number 4, if I write x cube, power is equal with 3, which represent as cubic. So this type of classifications are there. This we basically do not use, so I am removing it. But from here we really use linear polynomial, quadratic polynomial and cubic polynomial. Now we are going to give one example for linear polynomial. Linear polynomial example, I can say x plus a. This is the linear polynomial. After that, quadratic polynomial, we are writing one example. Ax square plus bx plus c. You can see that the highest power of x is equal with 2. So this is the example of quadratic. Now in case of cubic polynomial, example, what I can write, the highest power x cube, bx square, cx plus d. So this type of example you can take, and this type of classifications are there. First, we need to know the highest power of a variable. Highest power of variable. First we need to find this. If we are seeing that the highest power of x is equal with 1, then that polynomial is called as, that expression is called as linear polynomial. If the highest power of the variable is equal with 2, if I see, then that particular expression is called as quadratic polynomial. If the highest power of variable is equal with 3, then we say that particular expression as cubic polynomial, after that bi-quadratic, and so more. But we need to know about this. Up to this you need to know right now in 10th standard. So this is the classification and this is the introduction for the polynomial. So what we learned about the introduction of the polynomial. Polynomial is an expression. So first point is polynomial is an expression of variable along with constant. This is the first point we need to know. After that, highest power of variable defines the classification for polynomial. Example, linear, highest power is equal with 1, then quadratic, highest power is equal with 2, cubic, highest power is equal with 3, and so on. After that, number 3, what we need to know, that representation for polynomial. This is what we need to know. What is, if a variable equal with x, then generally we represent is p in first bracket x. This is the representation of an expression, that means a polynomial where the variable of that polynomial is equal with x. Now you can say that, sir, you are only using one variable. You are only using one variable. Can we use another variable with this? In that case, I can say that no, you can't use it. In case of polynomial, you will have to use only one variable. And if we are using x, then we have to represent it by small p in first bracket x. If you are using variable as y, if you use the variable as y, then you can use py. P stands for basically polynomial. So that's why, like this way, you can represent one polynomial. Now we need to know about the representation. So already we have learned about the representation, and the representation is px. Next, general representation for polynomial. First, linear. Px is equal with ax plus b. This is the general representation for the linear polynomial. Example, px equal with 2x plus 7. In this way you can represent it. Next, number 2, quadratic. In case of quadratic, px, the general representation is ax square plus bx plus c. Example, px equal with 2x square plus 3x minus 7. This is the representation for quadratic. After that, number 3, we need to know about the cubic. General representation, px equal with ax cube plus bx square plus cx plus d. Example, we can take 3x cube minus 2x square plus 9x plus 8. This is the example for cubic, and in this way you can take any kind of example. In your book you can see that there is a particular expression, and that particular expression given like this way: px equal with an x to the power n, an minus 1 x to the power n minus 1, like this. After that, a3x cube, a2x square, a1x, and after that a0. Like this way you will get a particular polynomial expression. No need to fear about it. This is a very simple thing. This is the general nth order polynomial. What does that mean? The meaning is the value of n you can decide. Like in this case, the value of n which I decide, that is equal with 1. So that's why we are using only this part: a1x plus a0, ax plus b. If I decide for quadratic, then obviously I need the value for n equal with 2. So that's why a2x square plus a1x plus a0, that means ax square plus bx plus c. Now in case of cubic, I need the value for n equal with 3. So that's why a3x cube plus a2x square plus a1x plus a0, that means ax cube plus bx square plus cx plus d. So in this way, this is the general nth order polynomial. So no need to worry about it. You just need to know about the application part. You need to know about how to configure a particular polynomial from this general nth order polynomial. So linear, quadratic and cubic, that you need to know very specifically for your 10th standard. Now, if we understand about this part completely, we will have to proceed for the next part, which is graphical representation. For graphical representation, there are two things you need to know. First, if I represent this polynomials in a graph paper, then what will happen? That we need to know. So first we will going to discuss about linear polynomial. This is what we are going to define right now through the graph. If I represent the linear polynomial in a graph paper, then what will happen? So first we need to know that if I represent a linear polynomial px equal with ax plus b, then this will represent a straight line on the graph paper. That we need to know. Okay, understandable this is? So linear polynomial basically represent a straight line. Now think about it. I am going to draw one particular straight line. Suppose like this. Like this. In these three pictures, you can easily see that this straight line intersect the x-axis. In this case, intersect the x-axis in particular one point. Now in case of this, if you can expand this like this way, this will going to also intersect the x-axis in a particular point. So in each and every cases you are getting, in this particular three cases you are getting a particular intersecting point where a line intersect the x-axis. This particular point, intersecting point, represent a very important term for this chapter. Very important term. This particular point represent a very important term for this chapter. Later we know about it. So first we need to know linear polynomial represent a straight line, and we can say that the straight line can once intersect the x-axis. If you think that a straight line can intersect the x-axis more than once, is it possible? I think that is no. Answer is no. Why? Let's see this figure. This is a straight line and this intersect at this particular point, and this straight line moves like this way and again cuts the x-axis. I don't think this is a straight line. I don't think this will right now a straight line. So that means straight line once intersect the x-axis. Intersect x-axis at only one point. I think that is clear. So linear polynomial represent a straight line which intersect x-axis at only one point. Now you have maybe a question, sir, each and every straight line, is it necessary to intersect the x-axis? That is also a very interesting point. Sir, if I draw a line like this, then this line is not going to intersect x-axis. Parallel line. So obviously, this line is not going to intersect the x-axis. In that case, sir, this is also a straight line and this is a linear polynomial. Then there are so many things maybe going inside your mind. Sir, if a line passes, then what happens? There are so many cases you may think. So from that particular point, I can say that intersect x-axis at only one point, that is true. But I am not saying each and every straight line is going to intersect. But if a straight line intersect the x-axis, then that intersection will be only one point. So the point is, linear polynomial represent the straight line among those straight lines which intersect the x-axis. Only intersect at one point. There is no any chance to intersect the x-axis more than one if the line goes to intersect that. But in case of this, you can see that these lines are not going to intersect the x-axis. So that means there exists some of the straight line. There exists some straight line or some linear polynomial which doesn't have any intersecting point at x-axis. So you also need to know about it. So that means I am going to write not all straight lines. For your remembrance, and from particular this point you will get 1 or 2 marks justification in exam. From this particular point, intersect x-axis at only one point, that is true for straight line, but not for all straight line like this. In that case, justification. In exam you will get justification regarding with this topic, and you will get 1 marks or maybe 2 marks short questions. is the linear polynomial part has been completed. Now we are going towards the next part, that is quadratic polynomial. Quadratic polynomial, if I write px equal with ax square bx plus c. In this case, this quadratic polynomial obviously not represent a straight line. This is not going to represent a straight line. This represent curves. This represent curves, not a straight line. So linear polynomial only represent the straight line. Quadratic polynomial represent curves. Example, x square. If I am writing a particular polynomial px equal with x square, then the representation will be like this. This is not a straight line. This is a particular shape of curve. Like this type of curve you can say for the quadratic polynomial. Over here you need to know about it that in case of quadratic polynomial, this intersecting point, how many times we are going to get that intersecting point? How many intersecting point we are going to get? In this case, you need to take note for it that in case of quadratic polynomial which represent a curve, get intersecting point in x-axis as equal with 2. So the point which you need to remember, linear polynomial represents straight line, intersect x-axis only one point. Quadratic polynomial represent curves, intersecting point on the x-axis equal with 2. In case of cubic polynomial, I think you can guess it. In case of cubic polynomial, I think you can guess intersecting point in x-axis equal with 3. Why this type of thing is going on? Is this directly related with the power of the variable? Yes. This exactly related with the power of the variable x. You can see that the linear polynomial, the variable power is equal with 1. This variable power is equal with 1. So that's why intersecting point we are getting 1. Next, quadratic polynomial. In case of quadratic polynomial, the highest power of x is equal with 2. So that's why intersecting point what we are getting at x-axis equal with 2. In case of cubic polynomial, the highest power is equal with 3 for the variable, so that's why we get the intersecting point in the x-axis equal with 3. So in this way, if you rise or increase the power, then you will get more and more intersecting point. So what we need to know from this particular point, that means the graphical representation, that thing you need to write. The thing you need to write is number of intersecting point on x-axis by the polynomial equal with highest this is what you need to know. One particular example. This is from the sample paper class 10th from this year. The question was given like this. This was a fill in the blanks. For this car, how many intersecting points we are getting, and so we can say that this is the first intersecting point, this is the second intersecting point, this is the third intersecting point. So how many intersecting points we are getting? 3 from this particular figure, and this intersecting point are called as the most important part. Intersecting points are called as zeros of polynomial. So the question was for 2020 sample paper mathematics class 10. This was the fill in the blanks question. How many zeros we are getting? The answer is 3 because intersecting point are 3. So from today's lesson, what we are going to learn, or what we have learned already: introduction, polynomial. What is the meaning of polynomial? The expression which contains the variable as well as the constant. Next, what we learn? The number of intersecting point on the x-axis by the polynomial equal with the highest power of the variable of the polynomial. Next, finally, what we learn? Intersecting points are called as the zeros of the polynomial. In my next class, we are going to discuss about the only thing, zeros of the polynomial. So before that, you need to recap this. Just go through the notes what I have given, and in the next class we will start this zeros of polynomial and relation between zeros and the coefficient. Thank you very much. This is the end of this class.